Hi guys, today we are going to be solving rational inequalities by using test intervals. So why is this a rational inequality? It's a rational inequality because we have a rational expression and inequality symbol, so altogether rational inequality. We are not given the green light to solve this however we like. We have to use test intervals, so it's this technique or bust. We are asked to use test intervals to solve the rational inequality. We are asked to write the solution set in interval notation. We may use a graphing calculator to find the zeros if we like, or we can freehand it, and we are asked to round all endpoints to one decimal place. Okay, so cool. So with that being said, what is the first step? So the first step is to fix it so we have a 0 on one side and a single fraction on the other. And that's very important. Why? Because when it comes to fractions, I'm naturally drawn to get rid of the fraction, to get rid of the denominator. But I have to bite my tongue on that because I can't do that for rational inequalities. We gotta keep the fraction. So do we have the first step done? Is there 0 on one side? Yeah, cool. Do we have a single fraction on the other? Cool. All right, so let's go straight to step 2. So step 2 says find the zeros. For rational inequalities, we are going to find the zeros of the numerator and then zeros of the denominator. So let's go ahead and find the zeros of the numerator. So let me just put my made up abbreviation for numerator. So if you want to know what makes the numerator 0, and you're going to write numerator equals 0. So the numerator gives us x squared minus 1 equals 0. And then we solve this however we like by factoring or whatever you want to do. In this case, we're going to use the square root method because there's no loose x. So let's go ahead, add 1 to both sides. And that will give us x squared equals 1. When we apply the square root property to get rid of the square, let's go ahead, square root both sides. And at this point, we'll add our plus or minus. And then we will tell the world that the zeros of the numerator are given by x equals positive or negative, whatever the square root of 1 simplifies to, which is 1. Okay, so the zeros are 1 and negative 1. So from a previous unit, when we were solving quadratic inequalities or polynomial inequalities, by using test intervals, the question is we're going to use the zeros to split the number line into test intervals. But the question I'm going to ask myself is this: are these zeros part of the solution or are they excluded? Well, we are going to look at the inequality symbol. If the inequality symbol has the equal to part, then the zeros are in. If the inequality symbol doesn't have the equal to part, then the zeros are out. So in this case, the inequality symbol has what I call the equal to part, so the zeros are in. So when we graph them, we're going to say closed circle. If you want to say bracket, I'm okay with that too. So to find the zeros of a rational inequality, we have to find zeros of the numerator and zeros of the denominator. So we already know what makes the numerator 0. We want to know what makes the denominator 0. But something that I want to point out is this: although we want to know what makes the denominator 0, we never actually want the denominator to be 0. Why? Because if the denominator equals 0, then something over 0 is undefined. So I'm just put a little love note. But denominator can't equal 0. So use an open circle. Okay, now that's kind of like a contradiction to what we just said. We had said, oh look, closed circle, because we have the equal to part. But yeah, but the denominator can't equal 0. So for the denominator, zeros of the denominator, we always have to use an open circle. There's no way around it. Why? Because we don't want the bottom to equal 0. Okay, that's enough chit chat. So let's go ahead and find the zeros of the denominator. So the denominator reads x squared minus 9. And if we want to know what makes it a 0, then we set it equal to 0 and we solve it however we like. For this problem, we're also going to use the square root method. So let's go ahead and isolate the squared part by adding 9 to both sides. And then we apply the square root property by taking the square root of both sides. So to undo the square, we're going to go ahead square root. And then at this point, we're going to put plus or minus. Okay, so we have x equals positive or negative 3. So let me go ahead and write it. So we have x equals 3, negative 3, and we have to use an open circle. Okay, fantastic. So what are we going to do? We're going to use these zeros to split the number line into test intervals. I'm having a moment in terms of where I should continue doing my work. I'll just continue writing below. Okay, so let's go ahead and locate these zeros. So we have a 1, negative 1, 3, negative 3. So we have a negative 3, negative 1, positive 1, and then positive 3. Close circles at 1 and negative 1. open circles at 3 and -3. Fantastic. So we have 1, 2, 3, 4 zeros, which is going to split the number line into 1, 2, 3, 4, 5 test intervals. So we go ahead, label them 1, 2, 3, 4, 5. Cool. Fantastic. So if we are asked to solve the rational inequality by test intervals, then we have to test each interval. Okay, so let's test them in order, starting with 1. So first test interval, we cannot necessarily read each other's minds, so we may not necessarily pick the same test value, but it doesn't matter what test value you pick, the interpretation will be the same. So in this case, I'm gonna test out -4. I think that's nice. So you can test out any number of your liking as long as it's in this interval. And if you want to test out -57, go for it. So where should you plug it in? So that original inequality looked pretty nice. Go ahead, zoom out. Okay, that original rational inequality is pretty nice. So let's go ahead, write it out. So we have x squared minus 1 over x squared minus 9 is less than or equal to 0. Cool. And I'm going to show you a little secret. So technically we're supposed to show all this work, but we're going to go ahead and use our calculator. Okay, we're going to enter this in our calculator. Okay, we're going to enter it. Bear with me. I didn't clear the screen, did I? Okay, yes I did. I'm a good host. Okay, so we're going to enter x squared minus 1 divided by x squared minus 9. Do we have to do what I'm about to do? No. Okay, you can generally plug it in, -4 into this, but I'm going to show you a quick way to plug it in, especially since we're going to have to repeat this process 5 times. Okay, and then let's go to table. So we're going to do second table. And then right now, okay, it's not on ask, so let's go ahead adjust our table settings. Okay, so we're gonna do second table set. So second table set. Right now the independent variable, which is our x, is on auto. I want it to be on ask, okay, because I want to enter in the x value. So then I think I put enter. Cool. So let's go back to table, second table. Did we enter the function? Yeah, okay, cool, we entered it. Second table. And then the question is, what do I get when I substitute a -4 for x? Calculator, tell me. We're gonna hit enter, and looks like we have about 2.1. Okay, so this is gonna give us 2.1 is less than or equal to 0. Okay, so again, if you had done it by hand, you would have gotten about 2.1. So I want to know, is 2.1 less than or equal to 0? And answer is no. Okay, 2.1 is not less than 0, so it doesn't check out. So because our test value, whichever one you selected, is not a solution, that means that none of the other values in this interval are also gonna check out. So let me just cross it out for dramatic effect. So this interval is not going to be part of the solution. Let's test out the next interval, which is given by the interval from -3 to -1. And again, we never use the endpoints. Test interval number 2, if I stick with integers, I'll use -2, but we're using a calculator. So if you want to use a decimal, go for it, but I don't want to confuse myself. So I'm going to test out -2. Oh, sorry, equals. And that's going to lead to the following. Okay, so when we substitute a -2 for x, what do we get on the left side? The left side, we get -0.6. So that's going to lead to -0.6 on the left. Inequality symbol, 0. So the question that I want to ask myself is this: is -0.6 less than or equal to 0? Well, last time I checked, it is. So it checks out. So because our test value is a solution, that means that every other real number in this interval is also going to be a solution. So let's go ahead and graph it. Do you have to graph your solutions along the way? You know, you don't have to, but the worst thing you can do to yourself is do all the algebra and then fail to answer the question. So love yourself. You know, you don't have to cross it out. I'm all about the drama at times, because, you know, yeah. So let's go ahead test out the third interval. So you can test out any number of your liking, picking decimals if you like. But if I was doing it by hand, I will stick with integers. So I will test out 0. So I want to know, is 0 a solution of the inequality? So again, we punch this into our calculator. Remember, we have x squared minus 1 over x squared minus 9. And I mean well, but if you're like, no, I must show everything, then go ahead, plug it in manually. Okay, so when x equals 0, let's punch it in 0. What will the fraction give us? So we have about 0.1, so that's going to lead to 0.1, inequality symbol 0. So the question is 0.1 less than or equal to 0? No, it's not. Okay, this is a lie. Okay, so because our test value is not a solution, that means that no other number in that interval is going to be a solution. So this interval is out. So 3 intervals tested, 2 more to go. So our fourth test interval, we want to test the interval from 1 to 3. I'll test out 2. If you want to test out 2.5, go for it. 1.5, I'm all for it. So when we test out 2, what is that going to lead to? Okay, so when x equals 2, the fraction simplifies to negative 0.6. Bringing down the rest of the expression, we have inequality symbol 0. Well, less than or equal to 0. So the question that I'm going to ask myself is this: is negative 0.6 less than or equal to 0? Yeah, it is. It is less than or equal to 0. So because our test value is a solution, that means that every other real number in this interval is also going to be a solution. So let's go ahead and graph it. Fifth and final test interval. So we want to test out the interval from 3 to infinity. So if I was doing it by hand, I would totally pick x equals 4. You know, if you want to pick like x equals 99, you know, go for it. So in this case, let's punch it in. When we substitute a 4 for x, what will the fraction give us? Okay, fraction gives us about 2.1. Okay, so fraction gives us about 2.1. Inequality symbol 0. So what I want to ask myself is this: is 2.1 less than 0? Answer is no. Okay, 2.1 is not less than 0. So let's go ahead and do this. So where am I? I lost my space. 2.1 is not less than 0, so I'm going to cross it out. So we have tested all 5 intervals. Let's go ahead, write the answer with confidence. So the solutions, if you graphed it, it's going to be the union of these 2 intervals. First interval from negative 3 to negative 1, where negative 3 is excluded and negative 1 is included. Okay, so interval from negative 3 to negative 1, where negative 3 is excluded and negative 1 is included. So remember, parentheses, bracket if you're in, parentheses if you're out. We have another interval, so let's go ahead, take the union, and it's going to be interval from 1 to 3, where 1 is included and 3 is excluded. So 1 is included and interval from 1 to 3, where 1 is included, bracket, and 3 is excluded, parentheses. So that is going to be the solution to the inequality. So the saying is that practice makes perfect. So let's go ahead and knock out another one. Maybe make it a little bit spicier. Okay, give me a sec. Okay, so same direction. So let's go ahead, come to the chase. So we have a rational expression, inequality symbol. So altogether we have a rational inequality. We are not given the green light to solve it however we like. We have to use test intervals. So again, is this technique or bust? So let's do this. First things first, remember, don't try to wipe out the fractions, because then you're not gonna find the zeros of the denominator. First things first, we need to fix it so we have 0 on one side and a single fraction on the other. So let's do this. So we want to have 0 on one side, single fraction on the other. So that will give us x cubed plus 3x squared plus 5x minus 6. So the fraction, okay, x squared minus 5x minus 1, and then the rest of the problem plus 1. Inequality symbol is greater than or equal to 0. Okay, so we have 0 on one side, but we need to work our magic so we have a single fraction on the other. So in this case, let's go ahead, add these bad boys. There's only one denominator, so that one denominator that you see will be your common denominator. Let's go ahead, take keep our cool, write the equivalent fraction so we can then proceed to add. So let's go ahead, I'm going to go ahead, write this 1 as 1 over 1, and then with confidence I'm going to multiply both the numerator and denominator by the common denominator just identified. Okay, you don't have to write LCD equals. I do that because I love speaking to myself. Okay, so I think we're good. Okay, so the first fraction has a denominator of x squared minus 5x minus 1. Our second expression now has a denominator of x squared minus 5x minus 1. The denominators are now the same, so we have green light to add. So let's do this. So to add, we're going to take the first numerator and then add to it the second numerator. Remind me not to use a highlighter anymore. So that will give us x cubed plus 3x squared plus 5x minus 6. Operation is plus, so we're going to add to it 1 times x squared minus 5x minus 1. The question is, do we really need the times 1? I mean, no, but students like it, so I give the people what they want. You can just go straight to plus the trinomial. X squared minus 5x minus 1, inequality symbol is greater than or equal to 0. Okay, so to solve a rational inequality, we want 0 on one side checked and a single fraction on the other checked. But let's just go ahead and make sure we simplify the fraction itself. Let's go ahead, distribute that 1, and then combine the like terms. So we have x cubed plus 3x squared plus 5x minus 6. We're going to go ahead, distribute that 1. So that will give us x squared minus 5x minus 1, and that's all over x squared minus 5x minus 1 is greater than or equal to 0. So again, we do have 0 on one side, single fraction on the other, but we have to clean up that fraction. Okay, when we combine like terms, there's only one cubic term or one term of degree 3. When we combine the squared terms, 3x squared plus x squared will give us 4x squared. When we combine the x's, 5x minus 5x, oh that's nice, gives us 0, one less thing to look at. And the sum of the constant terms, namely negative 6 and negative 1, will give us negative 7, and the denominator was already good to go. Fantastic. So again, before we go on to step 2, we need to make sure we have step 1 nailed. 1, do we have 0 on one side? Yeah. Do we have single fraction on the other? Yeah. Okay, so let's go ahead and do this. So now our next goal is to find all the zeros. So we want to find zeros of the numerator, and we want to find zeros of the denominator. So I want to know what makes the numerator 0. Okay, I want to know what makes the denominator 0. So the numerator gives us x cubed plus 4x squared minus 7 equals 0, and I want to know what makes the denominator 0. So again, the denominator can't equal 0, so have to use let me just put but denominator can't equal 0, so use open circle. Pretend you can read that. Okay, so use open circle. Yeah, I need to work on my penmanship. Alright, so the denominator is x squared minus 5x minus 1 equals 0. So the directions, I failed to highlight, but again, the direction says you can use a graphing calculator to find the zeros. So you know what, I'm gonna take advantage. So piggybacking on our number sense, this is a degree 3 expression or a degree 3 polynomial. Leading coefficient is positive, so it should look something like this because it comes from the graph of y equals x cubed. Okay, the degree is 3, so we're expected to have 3 zeros. Now, are the zeros going to be part of the solution? Yes, because we have the equal to part. So let me just write closed circle. Okay, so I put the dot in the wrong place. Okay, so let's go ahead, graph this. Okay, let's go ahead, find the zeros. Okay, y equals, where am I? We have x cubed plus 4x squared minus 7. Oh yeah, that's not right. So x cubed, get out an exponent, plus 4x squared minus 7, and then we go ahead and graph it. Okay, so the degree is 3, so we're expected to have 3 zeros. We have 1, 2, 3 intercepts. So yeah, so let's do this. So what I'm gonna do, I'm gonna go ahead and do just the x-axis only, and then I'm gonna do my 3 zeros, 1, 2, 3, and then I'll just do a quick sketch, something like that. And then I'm gonna ask myself, what are the zeros? Okay, so the zeros, I don't know how to spell zeros. X equals, okay, let's go ahead, find the first 0. Okay, so we're not going to do it by hand. Let's go ahead, tell the calculator second calc 0. Okay, second calc 0. Okay, option 2. And you find the zeros in any order of your liking. You know my style. I like to find them from left to right. Okay, so I'll find the 0 that's about, where am I? 1, 2, 3. That's about -3. Okay, so left, first 0. So put the cursor somewhere to the left. So the 0 is about there. Cursor is to the left, so we're good. Left bound, enter. Right bound. Put your cursor somewhere. So use your side arrows. So put the cursor somewhere to the right. 0 is right there, and the cursor is to the right. Enter. And then guess, you can just leave it there, or if you're an overachiever like me at times, then move it close. Okay. So we have that the 0 to 1 decimal place, because the direction says so, it's about -3.4. So let me go ahead, put a -3.4, and I'll put it right here too. Cool. So 1 0 down, 2 more to go. So second calc 0. Let me see if I can play with. Okay, that's a little bit better. So second calc 0. So that's about -2. Put your cursor to the left. Put your cursor to the right. Guess. And we have that the 0 to 1 decimal place is about -1.8. Okay, put it on the side. -1.8. Cool. All right, so 2 zeros down, 1 more to go. The next one is about +1. So second calc 0. Put the cursor somewhere to the left, somewhere to the right. Guess. And that's about 1.1 if I know how to round. Okay, so we found the zeros of the numerator, which is going to be -3.4, -1.8, and 1.1. Okay, so what are zeros of the denominator? And again, remember, for the numerator, we're going to do a closed circle because that's dictated by the inequality symbol. For the denominator can't equal 0, so it's always going to be open circle no matter what the inequality says. Okay, so let's go ahead and enter this function. So go back to y equals, and you can leave it there or clear it. It's in my way, so I'm going to clear it. So we have x squared minus 5x minus 1, and then we're going to go ahead and graph it. The degree is 2, so we're expected to have 2 zeros, and then this comes off the square function. The leading coefficient is positive, so it should remind me of, let me put my thought process, y equals x squared, so something like this. Cool. But if you're like, I don't have time for that because it was a while ago, then just go ahead and graph it and be genuinely surprised. Okay, so I'm just gonna go ahead, write down the x-axis only. Let me see where I can fit this. Yeah. Okay, cool, fantastic. Okay, so we're gonna just highlight the x-axis only. I mean, for you overachievers, you can put the y-axis, but the y-axis gets in my way. Okay, so we have the degree is 2. We're expected to have 2 zeros. We see 2 x-intercepts, so let's do this. So the first one is about 0, and the other one is I can't count. Okay, so let's go ahead and find the zeros. Second calc 0. Let me just do my graph. Okay, second calc 0. Okay, so left bound, put your cursor somewhere to the left. Got it? I don't know what I did. I'm not nervous, you're nervous. Okay, from the top. Second calc 0. Put your cursor somewhere to the left. It's right there. Oh, I put a plus sign by mistake. Enter. Put the cursor somewhere to the right. Enter. Move the cursor close to guess. Move the cursor close to the 0. And to 1 decimal place, that's about -0.2. So zeros gonna be x equals, I should say about, but I already put equals, about -0.2. Let me just put that here. And then this one is about 1, 2, 3, 4, 5. Okay, so second calc 0. So we said it's about 5. Let's go ahead, find the approximation or the exact answer. So remember to pause and rewind as many times as needed. Okay, that will give us 5.2 to 1 decimal place. Okay, let me just remind myself that these should be open circles. Okay, I think that's how you spell circles. Fantastic. Okay, so the numerator has 3 zeros. The denominator has 5. The denominator has 2 zeros. Let's go ahead and locate these 5 zeros on the real number line, and then we'll test out and we'll test out each interval. So I'm out of space, so let me go ahead and start a new column because we're trying to save a paper here. Bear with me. Okay, how high can I write? Okay, I'll zoom in a bit. Okay. Oh yeah. This is not like one of these beautiful videos, but it's okay. Okay, so the presentation may not be digital, but it's okay. I'll get you through the math. Okay, so the zeros are negative 3.4, negative 1.8, 1.1, negative 0.2, 5.2. If my eyes don't fail me, from left to right, we should have negative 3.4, and then I'll take a pause in a bit. So we have a line. As soon as we highlight a number on it, we have a number line. So we have negative 3.4. And then we have, I think, negative 1.8. And then we should have negative 0.2. And then we should have, hold on, negative 3.4, negative 1.8, negative 0.2. Then we should have 1.1, followed by 5.2. Okay. Let me go ahead extend it. Okay. So that is our number line. Fantastic. Now let's go ahead put the open or closed circles. We have closed circles at these first three zeros, negative 3.4, negative 1.8, and 1.1. So negative 3.4, negative 1.8, and 1.1. And because the denominator cannot equal 0, then we have open circles at the other two zeros, namely negative 0.2 and then 5.2. Okay. So we're at my open circle at negative 0.2 and 5.2. Okay, so we have 5 zeros, which will split the number line into 6 test intervals. So the first test interval will be the numbers that are less than negative 3.4. The second test interval will be the numbers sandwiched between negative 3.4 and negative 1.8. Test interval number 3, the numbers between negative 1.8 and negative 0.2. Test interval number 4, interval will be the interval from negative 1.2 to 1.1. I know, I feel like I'm so tired. Fifth test interval will be the numbers between 1.1 and 5.2, and the sixth and final test interval that we're going to check out is the numbers that are greater than 5.2. Okay, so let's go ahead and do this. Let's test out the first interval. As always, I would like for you to test them in order from smallest to largest, and you tell me what interval number you are testing. So and then we identify the test interval number. We identify our test value. We call it test value because it's a value that we're going to test out. You can test out any number of your liking as long as it's in that interval. Let's go ahead, test out negative 4. Go ahead, tell me where you're plugging it into. You can plug it into the original inequality, which is what you're supposed to do. But for me, it's so much easier to compare to 0. So I'm going to look for that inequality that's being compared to 0. So I'm going to look at this one. Okay, so let's go ahead and write it out. So we have x cubed plus 4x squared minus 7 all over x squared minus 5x minus 1 is greater than or equal to 0. So we are supposed to do it by hand. No, I lied. We can do it by hand, but we're gonna use our technology. Okay, but if you do it by hand, you just plug it in and then see if the left side is greater than or equal to 0. Okay, let's go ahead, use our calculator. Okay. So give me a sec. Okay, so let's go ahead test out our test value. Again, we can do it by hand, or we can use our calculator to fake do it by hand. But let's go ahead plug in the rational expression. You know, I'm gonna call it f of x, but in our calculator that would be our y equals. Don't forget to have good notation. You're gonna wrap up the numerator and denominator. If not, you're not really dividing these two polynomials. Okay, so let's open the numerator. That will be x to the third power. Get out of the exponent, plus 4x squared minus 7, close the numerator, fraction bar, divided by, open the denominator, x squared minus 5x minus 1, and go ahead, close the denominator, and then we're gonna test it out supposedly by hand, but with the use of our technology. So let's go ahead, look at our table of values. So we're gonna do second table. We're coming from the previous problem, so the table is already set to ask for the independent variable, or the x. These are the x values that we tested out from the previous problem. Let's just go ahead, hit delete, because they're in my way. Okay, new problem, cool. So we had said that we're gonna test out -4. So when x is -4, whether I do it by hand or I use a calculator, we're gonna have that the fraction simplifies to -0.2. Okay, we bring down the rest of the problem. We have is greater than or equal to 0. So my question is this: is -0.2 greater than 0? I know that you know that that's a lie. Okay, -0.2 is not greater than 0. So this interval is out. You don't have to cross it out, but I'm a visual person, so if I cross it out, it kind of highlights that we already tested that interval. Okay, so let's go ahead, test out the next interval. Test interval number 2. You test out any value of your liking. If I was doing it by hand, of course I will pick integer values. So let's go ahead, pick -2 or -3. I'll go with -2. And this is going to lead to the following. So again, you could generally do it by hand, or you can use your calculator. We're going to use our calculator. So we already saved this fraction into our calculator. Remember, we have y equals the fraction. So let's go back to our table. So when x is -2, let's go ahead, substitute, and the fraction should give us about 0.1. Okay, so that will lead to 0.1 on the left is greater than or equal to 0. So what I want to ask myself is this: is 0.1 bigger than 0? And that's the, what did they say, affirmative? Yeah. So our test value, whether it be -2 or any other number that you tested in that interval, is a solution, which means that every other real number in this interval is also going to be a solution. So let's go ahead, graph them. Cool. So 2 intervals tested, 4 more to go if I know how to count. Test interval number 3. So we pick any number in that interval. I'm going to stick with -1, yeah, because 0 is not here. 0 is in the fourth one. So again, as you're showing your work, I need you to tell me what interval number you're testing. I need you to clearly identify what test value you're testing, and then in terms of the outcome, you either show me the actual math, or you just show me where you plugged it into and you're good. Okay, so test interval number 3, I think we said we're testing out -1. Oh, I don't know why I put an arrow right here because I got nervous. Okay, that's just equals. Okay, so when we substitute a -1 for x, that's going to lead to the left side is greater than or equal to the right side. So the left side, according to our calculator, or if we generally freehanded, the left side should give us -0.8. Inequality symbol, 0. Okay, so the question that I need to ask myself is this: is -0.8 greater than 0? I know that you know that that's a lie. Okay, so because our test value is not a solution, then no other number in that interval is going to be a solution. Let's go ahead, release a little frustration. So fourth test interval. So this is a pretty tedious process, but if we do it with the use of our calculator, it can be less tedious because we don't have to actually substitute by hand our test value for the variable and then clean it up. So fourth test interval is the interval from -0.2 to 1.1. So if I was going to do it by hand, 0 is my favorite number. So let's go ahead and test it. Cool. So even though we are using our calculator, the test values that I select are the same test values that I would select if I was going to crunch in the numbers by hand. So when x is 0, the fraction simplifies to, according to our calculator, 7. Okay, so the left side should give us 7, and I want to know if that's greater than 0. So I'm like, okay, is 7 greater than 0? Last time I checked, it is. Cool. All right, so let's go ahead, plug in check. Oh, sorry. Where is 0? So 0, our test value is a solution. That means that every other real number in that interval is also a solution. So let's go ahead and graph up. So 4 intervals down, just 2 more to go. Fifth and almost final test interval. So we pick a test value within this interval. I'll stick with 2. What if you want to pick 2.99? I don't care what you pick, as long as you tell me the interval you're testing, interval number, you clearly identify your test interval, you're gonna be good. And again, you either punch it in and show me the work by hand, or just tell me where you are getting your numbers from. So when we substitute a 2 for x, the left side should give us some number, and I want to know if it's greater than 0. According to our calculator, if x is 2, the left side simplifies to about negative 2.4. So I want to know, is negative 2.4 greater than or equal to 0? Last time I checked, that is a lie. Negative 2.4 is not greater than 0, so it doesn't check out. So because our test value is not a solution, that means that no other real number in that interval is also going to be a solution. Let's release that frustration. All right, test interval number 6. With your permission, we'll test out 6. If you want to pick 99, go for it. It's in that interval, so you're good. When we substitute a 6 for x, whether we do it by hand or we punch it in, that will give us 70.6. Okay, so we have 70.6. I want to know, is that really greater than or equal to 0? Yeah, totally. Okay, so because our test value is a solution, that means that all the real numbers in that interval are also going to be solutions. All right, so we are done in terms of showing the work, but now let's just go ahead, spit out the answer. Okay, so in this case, from our number line, we have 3 graph pieces, or 3 graph areas. So we're gonna have 3 intervals, and we'll connect them with the union symbol. So let me just put A and S for answer. You don't have to put A and S. You can just write the answer and then box it. Okay, so the first interval is going to be the interval from negative 3.4 to negative 1.8, where both endpoints are included. Let's go ahead and write that down. Negative 3.4 to interval from negative 3.4 to negative 1.8, where both endpoints are included. We have another interval, so we're going to say union, but I'll read it as or. Next interval is going to be interval from negative 0.2 to 1.1, where negative 0.2 is excluded and 1.1 is included. So negative 0.2 to 1.1, we had said where negative 0.2 is out, so parenthesis, and 1.1 is in bracket. Cool. All right, so 2 intervals down, 1 more to go. Let's go ahead, take the union of the third and final interval. Okay, so the third piece, we want the numbers that are strictly greater than 5.2. so in interval notation, it's going to be from 5.2 to infinity, where 5.2 is excluded. So interval from 5.2 to infinity. The infinities don't represent specific numbers, so they always get parentheses, and 5.2 is excluded. So that's it, man. So that's pretty awesome. I have faith that you're going to rock your next exam. Good luck, guys.